everybody, it's Miss Billingsley again. I hope you had an awesome spring break despite the current circumstances, but hopefully you made the most of it. Now, we are going to get back to learning today with a new standard and our final standard for this unit, believe it or not, which is over equations of circles. So let's go ahead and write that on the top of our papers. It is standard 6.K5.1. And we are learning about equations for circles. Now, you may have never heard of this before. What is an equation of a circle? Well, it is an equation that produces a circle on a graph, and it kind of makes sure that all the points are on it all the way around the circle from the radius. So the two things that we need in order to create an equation of a circle are, one, the h and k values represent the center point, and h is going to be the x value of that center. The k value is the y value of the center point. And the last thing that we need is the radius, the length of the radius. So with these two things, we can create an equation for a circle. So there's a couple different situations we're going to be looking at today. The most common one is when we're given a center and a radius. So let's start there. Taking a look at example number 1, we are asked to write the equation of a circle with a center point at 0, -5, and a radius of 9. So when we're given these two things so explicitly, really all we need to do is plug them into the formula. So I'm going to start by labeling everything with the colors that I used above. 0 is going to be my h value, -5 is my k value. Those are the x and y values of my center point. And then 9 is the radius, the length of the radius. So now what I need to do is plug each of these things into the standard formula, into my basic formula up here. So what we have is x. X is always there and never gets replaced. And then we're going to subtract h. For me, that is 0 for this example. And then we square that. And then we want to add y minus the k value, which is -5. And then square that. And what that is equal to is the radius squared. So in this case, 9 squared. Okay, so this, if we were to type this into Desmos, we would get a perfect circle with a center at 0, -5, and that has a radius of 9. You're welcome to try that out if you like. But in order to get, all the points and for it to be completely proper, what we need to do is simplify some things. I see a couple things that can be simplified here. So first, what I see is a -0. -0 does not affect the value of x. So what we can really say is just x squared. We don't really need to subtract 0. 0 is nothing. So what we can do is change that into x squared and then add y. And then I have this double negative, and we know that that turns into a positive. So y plus 5 squared. And then we can go ahead and simplify 9 squared, which is 81. Okay, and this is going to be our final answer. This is the most simplified version of the equation for our circle with a center at 0, -5, and a radius of 9. Okie doke, let's go ahead and take a look at the second one. You try. Okie doke, let's start by labeling everything. Hopefully you got the correct answer, but we're going to check our work together. We have our h value of -10, our k value of 4, and then our r value of 3√7, which is a little bit trickier than what we had above, but still manageable. So let's start with plugging in our numbers. X minus -10 squared plus y minus 4 squared is equal to 3√7 squared. Okay, and then what we want to do is simplify if possible. I see some double negatives here, and then I know I can simplify this number. It might take a little bit of work, but we can do it. All right, that double negative turns to a positive, so we're left with x plus 10 squared plus y minus 4 squared equal to, let's see if we can square this. In our unit 4, we learned how to simplify radical numbers. So when we square something, it's really just multiplying it by itself. So what we really have here is 3√7 times 3√7. and we learned that we can multiply the like terms. So here we can multiply 3 times 3 and get 9. I can also multiply my root numbers since they are both roots, and then I get root 49. Okay, but if you remember square numbers, perfect square numbers, 49 is one of those. So if we use our jail method, sorry about that. 7 and 7 are two factors of 49, and they would both come out. So we're left with 9 times 7, which is 63. So our final answer here is going to be x plus 10 squared plus y minus 4 squared equals 63. Okay, again, if we were to type that in Desmos, we would get the circle that we were looking for. Okie doke. Hopefully that is simple enough, but it's not always going to be that simple. Sometimes the situation is different and we're not given those two things explicitly. We're given information that lets us find them, like with our next example. Sometimes we're given the center point and another point on the circle. So let's clarify here. I'm going to write this down. We need the center point and we also need the radius, but what we're given here is the center and a point on the circle. Because I'm given this point on the circle, I'm going to be able to find my radius. And the way that we can do that is using the distance formula. Because if you think about the center of a circle, it connects to every single point on the outside of the circle. So we really can use any point on the circle to find the radius, and then we can write our equation. So for this particular situation, we are going to need our distance formula. So let's go ahead and write that down. It is the big square root of x2 minus x1 squared. Why is my stuff moving all around? Sorry, guys. Plus y2 minus y1 squared as well. Okie doke. So it doesn't matter which point is x1 or x2. What we're given in this particular problem is the point 1, -3 that's on the circle, and it has a center at -1, 1. So I'm just going to go with the order that they're in and going to call this one x1, y1, and this one x2, y2, and go ahead and plug those into my distance formula. So what we have here is -1 minus 1 squared plus 1 minus -3 squared. And then we can turn to our calculator, type all of that in at once. I'm going to go ahead and jump to that because I've done the work ahead of time. And what we get here is the square root of 20. Whoops, that's kind of funky. Okay, we can simplify the square root of 20 and it becomes 2 root 5. Let's go ahead and simplify if possible. So what this is actually my radius. Although we found the distance, it actually is the length of my radius at the same time. So we're going to use that radius, and then we're going to use our center point that was given, which was this -1, 1 point. So I'm going to go ahead and label with the colors that we used above. And then just go ahead and plug those all into my equation of a circle formula, which is x minus x1, which in this case is x2. Sorry if that's confusing. Plus y minus y2, which is 1 squared, equal to the radius squared. So 2 root 5 squared. All right. That is enough to satisfy Desmos, but we can simplify, of course. So here, if we do simplify, we get x plus 1 squared plus y minus 1 squared equal to, remember, multiplying a radical by itself gives us some radical cancellation. So in this case, we actually end up with 2 root 5 times itself, which gives us 4 root 25, which is 4 times 5. So that is 20. So our final answer here is 20. Okie doke. So for this particular example, we had to use the distance formula to find the radius and then plug that in. So let's go ahead and try the next example. Okie doke. For our distance formula, we would get the square root let's go ahead and label our points, x1, y1, x2, y2. Okay, so what we're going to end up with is -2 minus 0 squared plus -1 minus 6 squared. And according to our calculator, that leaves us with the square root of 53, which I believe is prime. So I don't think we can simplify that at all. Remember, this is our radius, so we are going to use this in our formula. And our center point was -2, -1. So let's use those and write out our equation. So we get x minus -2 squared plus y minus -1 squared equal to the root of 53 squared. All right, we know we can simplify. So here we get x plus 2 squared plus y plus 1 squared equal to 53. When we square a square root, they cancel each other out. So here we're left with x plus 2 squared plus y plus 1 squared equal to 53. All right, that is our second scenario. The last one we're going to be looking at today is when we're given 2 endpoints of the diameter. So our last situation is 2 endpoints with a diameter. When we're given this, it is the most work required from us because the diameter is nowhere used in our circle equation. So we're going to use that, find the diameter using the distance formula, cut that in half to find the radius, and then we can also use the midpoint formula to find our center. So in this case, we're not given anything that we need. We have to find it all, but we are fully capable of doing so. So let's start with example number 1 here using the distance formula. What we want to find here is the diameter, and then we know that the radius is half of that, so we're going to cut that in half. So again, it doesn't matter which is which, so I'm just going to label these in the order that they were given. And go ahead and plug these into my distance formula. So here we get 4 minus 2 squared plus 1 minus -5 squared. Okay, so we'll type that into our calculator, see what we get. And we get the square root of 40, which can be simplified as well, and that simplifies to 2 root 10. Remember, this was our diameter. And we don't really need the diameter. What we need is the radius. So if I cut that in half, I would take 2 root 10 divided by 2, which gives me just root 10. So in this case, my radius is square root of 10, which cannot be simplified any further. So we're going to leave it there. What we also need is to find the center point. Now, if we're looking at a diameter, smack in the middle of it is going to be the center of my circle, no matter where the diameter is. So we're going to use the midpoint formula to find our center. And remember that the midpoint formula takes the x's and adds them together, and then divides them by 2, and then takes the y's and adds them together, and divides those by 2 as well. So in this case, our center point is going to be wherever 2 plus 4 divided by 2 is, and then -5 plus 1 divided by 2. So in this case, we get 6 divided by 2, which is 3, and then -4 divided by 2, which is -2. So my center point is here at 3, -2. I'm going to go ahead and label those. Also, I'm going to white out this second problem so that I have room to write. Bear with me. Okie dokie. So we're going to take what we're given, what we found using distance and midpoint formulas, and go ahead and write our equation for this circle. So again, we take x minus the x value of our center, which is 3, and then that is squared. And then we want to add the y's, which is y minus -2 squared. and it's equal to the radius squared, which is the root of 10. Of course, we need to simplify if possible. X minus 3 squared does not simplify, but here we have a double negative, so we get y plus 2 squared. And the root of 10 squared is just 10. Those cancel each other out. So here is our final equation. Okay, I'm gonna leave you with this final example. I know I whited out that last one. We don't have to do that, but let's try this one. I want you to try to write the equation for the following circle. What you're given is a circle, a picture of it on a graph. So what you need to identify is where is that center point and what is the radius of this circle, and then go ahead and write that. Okie doke. Right here, we need to identify the center point, which is right at this black dot, and the coordinates of that point are at -3, +1. Okay, and I also need to identify my radius, which is going to be the distance from the center to any point on the outside of the circle. It's, of course, easiest to go straight if possible. Otherwise, we'll have to use that distance formula. But this one is nice and straight for me. I can go right to this point here. And the number of units is 3 units. So my radius is 3. And then my center point is at -3, 1. Okay, so we have everything we need to go ahead and write this equation. We're going to take x minus -3, square that, and then add y minus 1 squared, and then we're going to take 3 squared, equal to 3 squared. All right, simplify if possible, which we can, x plus 3 because of the double negative. Add y minus 1, no simplification there. But I can simplify 3 squared, and that gives me 9. So my final answer is x plus 3 squared plus y plus 1, y minus 1 squared equal to 9. Okie doke, that is all for today. We're going to extend on this at a later time, but we will call it quits. I hope you have a great day. Thank you so much.